Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal and this lecture on compound interest. In this lecture, we are going to start with definition of the compound interest in the first section. And then we will study the formula to compute compound interest and we will see some examples as well. And then we will see some important concepts of compound interest. And in the section 4, we will see the difference between simple interest and compound interest on sum for n years, in which we will see difference between simple interest and compound interest on sum for 2 years and 3 years. And in the 5th section, we are going to study effective rate for n different rate of interest. And in this, we will study the effective rate for 2 different rate of interest, and then we will study the effective rate for 3 different rate of interest. So in the last section, we will solve some problems on compound interest. So let's start with the definition of compound interest. So the compound interest is a financial concept where interest is calculated on both initial principal amount and the accumulated interest from previous periods. So in the simple words, I can say we are provided interest on interest. So here you earn more money. So it involves adding the interest to the principal amount, resulting in compounding effect. So the formula for compound interest is if A is the amount and P is the principal, then the rate of compound interest is R and T is number of years. Then amount A is equal to principal times of 1 plus R upon 100 whole to the power T. And a simple compound interest will be given by A minus P. And if I have to write compound interest in the form of A and P, putting their values, I will have P times of 1 plus R upon 100 की power T minus 1. Let us have a look over the example on the formula that we have studied just now. Find the amount if 10,000 is invested at 10% per annum for 2 years when compounded annually. So we know A is principal into 1 plus R upon 100 into to the power T. And from the given data, principal is given to be 10,000 and rate is given to be 10% and time is 2 years. So amount will be equal to 10,000 times of 1 plus 10 upon 100 whole square. So when you simplify this, you will get 10,000 times of 1 plus 0.1 whole square. So amount will be 12,100 rupees. Second example, find the compound interest on 12,600 for 2 years at 10% per annum compounded annually. So the principal amount is given to be 12,600 and the rate of interest is 10%. The time period is equal to 2 years. So amount will be equal to 12,600 into 1 plus 10 upon 100 whole square. So A is equal to 12,600 times of 1 plus 0.1 whole square. So amount A will be equal to 15,246. So the simple interest, so the compound interest is equal to total amount minus principal, that is 15,246 minus 12,600, which is equal to 2,646. Let us now have a look over some important concepts of compound interest. So the compound interest is calculated on these bases. If we have to, the compound interest is compounded annually, then the rate will be R% and time will be T years. And if after half year, if the compound interest is added, compounded half yearly, then the rate will be r upon 2% and the time will be t into 2. If it is done quarterly, then the rate will be r upon 4% and time will be t into 4 years. And if it is done monthly, then rate will be r upon 12% and the time will be t into 12 years. If there are distinct rate of interest for distinct time periods, so the rate of for first year will be r1%, then the rate for second year will be r2%. The rate of third year is r3% and so on. So then the amount is equal to P into 1 plus R1 upon 100 into 1 plus R2 upon 100 into 1 plus R3 upon 100 and so on. So here the interest rate is changing every year. So in that case you are going to use this formula. A certain sum becomes m times of itself in t years on compound interest. Then the time it will take to become m to the power n times of itself is t into n years. Let us now see the difference between CI and SI on sum for n years. So let us first of all see the difference between CI and SI on sum for 2 years. So the difference between CI and SI on sum P, principal P in 2 years at rate of R% of compound interest will be, for 2 years, is simple compound interest minus simple interest equal to PR square upon 100 square. For example, Aman invested a sum of money at compound interest of 10% per annum for 2 years. So the difference between the compound interest and the simple interest for this period is 400. Find the principal amount. So the solution, compound interest and the simple interest difference for 2 years is 400 rupees. And the rate is equal to 10% per annum and the time is 2 years. So for 2 years, compound interest minus simple interest is equal to PR square upon 100 square. So this formula is already seen in the previous slide. So when you substitute the values, you will have 400 rupees is equal to P into 10 square upon 100 square, that is equal to 40,000 rupees. Difference between simple interest and compound interest on sum for 3 years. So the difference between compound interest and simple interest on a sum P in 3 years at rate of R% compound interest will be compound interest minus simple interest equal to PR square into 300 plus R upon 100 cube. So let us have a look over an example. A sum of money is invested at a compound interest rate of 10% per annum for 3 years. The difference between the compound interest and the simple interest for this period is 620 rupees. So find the principal amount. So here it is given that the compound interest and the simple interest difference for 3 years is 620 rupees and the rate is given to be 10% per annum and time is 3 years. So we know for 3 years compound interest minus simple interest is given by PR square times of 300 plus R upon 100 cube. So it will be 620 rupees is equal to P into 10 square into 300 plus 10 upon 100 cube, which is equal to 20,000 rupees. So the principal amount is 20,000. Let us now see the fifth section, which is effective rate for n different rate of interest. So in this section, first thing we are going to see is effective rate for 2 different rate of interest. If the rate of interest in first and second cycle are X% and Y% respectively, the compound interest for 2 years will be X plus Y plus XY upon 100. And if the rate is same R%, the compound interest for 2 years is 2R plus R square upon 100. In the effective rate for 3 different rate of interest, it will be if rate of interest in R in first, second and third cycle is X%, Y% and Z% respectively. So compound interest will be X plus Y plus Z plus XY plus yz plus zx upon 100 plus xyz upon 10000%. So if the rate of interest R% for 3 consecutive years, so it will be CI equal to 3R plus 3R square upon 100 plus R cube upon 10000, that is 10,000. So let us have a look over an example. A man invests rupees 5,000 in a bond which gives compound interest at 4% per annum during the first year, 5% per annum during the second year, and 10% during the third year. So how much amount the man will get at the end of third year? So the compound interest for first year is 4%, and the compound interest for second year is 5%, and the compound interest for third year is 10%. So we know compound interest is equal to x plus y plus z plus xy plus yz plus zx upon 100 plus xyz upon 10,000. So the effective rate is equal to 4 plus 5 plus 10 plus 20 plus 50 plus 40 upon 100 plus 200 upon 10,000%. So it is equal to 20.12%. So the compound interest is equal to 5,000 into 20.12%, which is 1,006 rupees. So the amount is P plus CI, that is 6,006 rupees. Question number 1. So now we can start with exercises. If the amount is 2.25 times of the sum after 2 years at a compound interest compounded annually, the rate of interest per annum is. So let the principal be P and time is 2 years, and the amount after 2 years becomes 2.25 P. So the rate of interest, let us suppose, be R. So we know the formula A equal to P times of 1 plus R upon 100 to the power T. So the solution 2.25P is equal to P times of 1 plus R upon 100 whole square. So it is equal to under root 2.25 equal to 1 plus R upon 100. So which when simplified give you R equal to 50% per annum. So the option correct here is option D. Question number 2. A sum of money becomes 125 upon 64 times of itself in 3 years. Find the rate of compound interest. Let the principal be P rupees. So time is given to be 3 years and the amount is 125 upon 64 P and the rate of interest is R%. So by using the formula A equal to P times of 1 plus R upon 100 to the power T. So when you put the values, you will have 125 upon 64 P equal to P times of 1 plus R upon 100 to the power 3. So when this is simplified, you will get 5 upon 4 equal to 1 plus R upon 100. So it will be 5 upon 4 minus 1 equal to R upon 100. And when you simplify this, you will get R equal to 25% per annum, which is option A. Question number 3. At what rate percent per annum will rupees 2304 amount to rupees 2500 rupees in 2 years compounded annually? So the solution, the principal is equal to rupees 2304 and the time is 2 years. So the amount will be 2500 rupees and let R% be the rate of interest. So by using the formula, we have A equal to 1 plus R upon 100 to the power T. Put the values, you will have 2500 equal to 2304 times of 1 plus R upon 100 whole square. So it will be 2500 upon 2304 equal to 1 plus R upon 100 whole square. So this becomes 2 upon 48 equal to R upon 100. And that means R is equal to 4.16% per annum. So the option correct here is option A. Question number 4. If the amount received at the end of second and third year at compound interest on a certain principal is rupees 9,600 and rupees 10,272 rupees respectively, what is the rate of interest? So we know the formula to find the compound amount is A equal to P times 1 plus R upon 100 to the power T. So A is given to be 9600 and is equal to P times 1 plus R upon 100 whole square, which is equation number 1. And second, for third year, it becomes 10,272, which is equal to P times 1 plus R upon 100 whole cube, which is option 2. So dividing equation 2 by equation 1, we get 10,272 upon 9600 equal to 1 plus R upon 100. So it will be 1.07 equal to 1 plus R upon 100, that is 7% per annum. So the option correct here is option A. Question number 5. A certain sum amounts to rupees 2,80,900 in 2 years at 6% per annum. Interest compounded annually. So the sum is. So let the principal be P. Then A is equal to principal into 1 plus R upon 100 to the power T. And amount is 2,80,900. And R is 6% and time is 2 years. So this all information is already given to us in the question. So when you substitute the values, you will have 2,80,900 equal to principal times 1 plus 6 upon 100 whole square. It will be 2,80,900 equal to principal times 53 upon 50 whole square, which gives 2,50,000, which is principal amount. So the option correct here is option C. Question number 6. A sum of money invested at compound interest triples itself in 6 years. In how many years will it become 81 times of itself at the same rate of compound interest? So recall the formula for compound interest is amount equal to principal into 1 plus R upon 100 to the power T. It is given that the sum of money triples itself in 6 years. So if the principal was P, then the amount after 6 years will be 3P. So 1 plus R upon 100 to the power time, that is 6 years. So when you simplify this P and this P get cancelled, you will have 3 equal to 1 plus R upon 100 to the power 6. So that is 3 to the power 1 upon 6 plus equal to 1 plus R upon 100, which is equation number 1. So again, the sum of money becomes 81 times itself at the same rate of compound interest. So 81P equal to P times of 1 plus R upon 100T, and it is equal to 81 times of 1 plus R upon 100T. Now put the value of 1 plus R upon 100 from equation number 1, we get 81 times of 3 to the power 1 by 6 to the power T. So T is equal to 24 years. So the option correct here is option A. Question number 7. A sum amounts to rupees 8,028 in 3 years and to rupees 12,042 in 6 years at a certain rate percent per annum. When the interest is compounded yearly, find the sum. So the solution, let the sum be P. Then amount is equal to principal times of 1 plus R upon 100 to the power T. And amount is given to be 8,028. And it is equal to P principal into 1 plus R upon 100 to the power 3. That is time, which is equation number 1. So here again we have 12,042 equal to 8,028 times of 1 plus R upon 100 to the power 3. This gives equation number 3. Now after dividing 2 by 1, you will have 12,042 upon 8028 is equal to 8028 upon P. And when this is simplified, you will have principal equal to 5352. So the option correct here is option A. Question number 8. A sum of money amounts to rupees 3600 in 4 years and rupees 5400 in 6 years on a certain rate of compound interest. What will be the amount after 10 years with the same rate of interest? Let us have a look over the solution. Let P be the principal and R be the rate of interest. Then we have A equal to principal into 1 plus R upon 100 to the power T. And amount is 3600. Principal is unknown, 1 plus R upon 100 to the power 4, which is equation number 1. And when we do it for 6 years, we have 5400. So 5400 is amount, that is principal, 1 plus R upon 100 to the power 6. This gives us equation number 2. So when you divide 2 by 1, you will have 5400 upon 3600 equal to 1 plus R upon 100 square. Now taking root both side, you will get, and simplifying, you will get P equal to 1600. So now after 10 years, amount is equal to 1600 into 1 plus R upon 100 whole square to the power 5. So it will be 1600 into 3 by 2 to the power 5, which is equal to 12,150. So the amount after 10 years will be 12,150. So the option correct here is option D. Question number 9. A sum of rupees 5,000 amounts to rupees 7,200 in 8 years at a certain rate percent per annum. Interest rate compounded yearly. What will be the compound interest on sum of rupees 6,550 in 4 years at the same rate of interest? So let us have a look over the solution. Let the rate be R, and then A is equal to P times 1 plus R upon 100 to the power T. So 7200 equal to 5000 times 1 plus R upon 100 to the power 8. So which is equal to 72 upon 50 equal to 1 plus R upon 100 to the power 8. So we have 1 plus R upon 100 to equal to 6 by 5 to the power 1 upon 4. So we get P equal to, so when P is equal to 6550 and T equal to 4 years, then amount is equal to 6550 times 1 plus R upon 100 to the power 4, and substitute the value of R. You will get amount is equal to 1310 into 6. That means compound interest is equal to A minus P, that is 1310. So the option correct here is option D. Question number 10. Rupees 60,000 is invested at a certain rate for certain even number of years, compounded annually, grows to rupees 63,654. To how much amount would it grow if it is invested on compound interest at the same rate for half the period? So the solution, amount is equal to principal into 1 plus R upon 100 to the power T, where A is amount, P is principal, and R is the rate of interest in percent, and T is number of years. In this case, both R and T are not known, but principal and amount are given. So we have 63,654 equal to 60,000 into 1 plus R upon 100 to the power T. So simplify this, you will have, when the period is half, the formula for amount A1 becomes A1 equal to 60,000 into 1 plus R upon 100 to the power T by 2. Hence multiplying factors becomes the square root of the original multiplying factor. Hence A1 is equal to 61,800. So the option correct here is option A. So thank you very much. That would be all for this lecture, and I'll see you in the next class with more questions on compound interest.